Yeah, why don't you?
Try to move like this area.
Yep. Oh, okay. Yep.
Here with this camera. So we are about to start. Please quiet. Okay. So Walsh is going to talk about super privileged containers. So please invite him here.
Okay. So I had insomnia last night, and I was up till about 3 o'clock this morning, and so I actually got the presentation done then. So you might see some sleep-deprived slides here and spelling mistakes, things like that. So let's get started. There's probably a lot of content. I have a lot of demo, but I've been told that I might be able to sneak a little bit into lunchtime if we run over. So this is an actual picture in China. They actually have Unix-ware containers, which I always thought was kind of cool. And of course, they're super containers. So we have a problem statement. So some of this technology is coming out of the atomic host, needs for the atomic host. On the atomic host, we don't supply yum install. There's no way currently to install an image. You have to go out and rebuild an OS tree and then stuck it in. So, and one of the goals is to keep the atomic host to a minimal in size. So the question we get from when we talk to customers and people using atomic, if you get onto an atomic host, instantaneously there's going to be one command you're missing, and it'd drive you nuts. So if you get on an atomic host, it's like, oh, I need ping, or I need trace. Ping's probably there. I'm going to get Colin mad at me in a second, but trace route or strace, GDB. There's these tools that are missing that everybody expects, and they all do yum install, and then it comes up and says yum doesn't exist on the machine. So how do I admin a machine without these commands? Every customer we've talked to about an atomic host has their own pet project, their own pet tool that they put on all their machines, and they want to install it on it. So how do they do that? We have on the Atomic team, Project Atomic team, we have a rule for Atomic that says if you want to get your thing into the base Atomic build, you have to prove that it can't run in a container. So we're moving things like our syslog, we're moving some of the source reporting, SAR tools, things like that are normal on a Red Hat environment that, for support people, we're moving all that stuff into containers. We're even looking into moving in SSD into a container and potentially other stuff. So what super privileged containers are all about, I want to ship an application that will manage the host, okay? So we want to ship, management applications, or I want to ship an application that manage other containers. How do I do that using containers? So really that's what the goal here is. So for some reason this looked a lot fancier when I did it before. I was supposed to step these in, but I'll live with it. Super privileged containers is really just a concept. So I've had product management at Red Hat talking, when are we going to have the super privileged container thing? When are we going to have it? And I keep on saying it's really just a concept. It's a way of running containers. A way to run certain types of containers. So SPC will allow you to manipulate the host from inside the container. SPC and also can be used to manage other containers. I guess I'll just keep going. Okay, so this is supposed to step through this. It's supposed to be funny. But basically, the first step of this is you're supposed to be you need to turn off the security, because if a container, right now, if you saw my talk 2 days ago, all I talked about is how we were containing containers, trying to contain it. Well, if you want a container that can actually manage the host, you got to turn off the security. So wait, what did Dan Walsh just say? Turn off the security, and then I figure this is going to go out very quickly. And then we go to this. Okay. So a privileged container, right? Anybody who's played with Docker knows that -- privilege is available. And what that does is it turns off the Linux capabilities, turns off SC Linux separation. It disables seccomp and user namespace separation. It disables mounting of file systems read-only, and it allows you to create any Linux devices you want. So as soon as you say -- privilege, that turns off all the security. It's 740 on steroids, okay? It just shuts everything down. So as soon as we have now this is just talking about privileged container. A privileged container now all of a sudden can break out and do stuff on the machine, but it still has things in its way. So what we really want to do is get to the point of having a super privileged container. And what a super privileged container does is we turn off the namespaces. So the namespaces that separate Linux containers sort of get in the way. So if I'm running a container, a super privileged container on a system, I want to see all the processes on the system. Or I want to see the real network devices on the system. Or I want to see, I want to be able to manipulate the real /dev. And in some cases, I want to, work with IPC. So if I wanted to interface with like X stuff, I don't want to be separated from the kernel. From the OS. So we need to be able to turn off these. So over time, we've been adding all these patches to Docker to basically allow us to disable features in Docker for namespaces. A second part of this, so now if we run a Docker container that sees the real network, sees all the processes on the system, sees the same shared memory segments, the next thing we want to do is we want to see the file systems. Since we're shipping, one of the real goals of containers is the ability to ship software, right? So we still need to take advantage of the mount namespace. Well, we do up till now. Potentially, we could get rid of the mount namespace at some point. But the mount namespace really is all about keeping our content. So we're still going to have our own version of /user, our own /. All the content is still separated from the host. But what we need to do is start mounting, or volume mounting, the host into the container. So if we volume mount in /run, all of a sudden we can talk to systemd. Because systemd listens on dbus inside of /run. We can start to talk to dbus. We can communicate with all the dbus services if we're using the real /run on the system. Secondarily, we propose that we mount in / into /host. So the entire operating system will be mounted at /host inside of a super privileged container. So it allows container processes to communicate, to actually modify files in the host file system. But you have to understand you're running in a container, so you have to understand you have to go into /host. So tools like Source Report, which is our support organization in Red Hat, have rewritten Source Report or changed Source Report to understand that it's running in a super privileged container and therefore can see the host. So I always love this picture of Leonard. So let's do a demo. And of course, 5 minutes ago, my Docker was broken, so hopefully I fixed it. Okay, so first of all, we're going to just do a Docker run. This is the standard container. Is this good size up there? Okay, so if I just show the processes running the system, you see that it's running with an SE Linux label. It's locked down in the container. If I went around and showed you the mount table, you see them all mounted, read-only, all that stuff. And as you can see, I only see the two processes running in the container. So now I'm going to exit out, and now we're going to switch to privileged. Oop. Oh, yeah. Yep. Thank you for bailing me out on typos. So now if I go and look at the process. I see instead of running as a confined user, I'm now running as an unconfined user inside of the shell. But basically, pretty much the same thing. I'm still only seeing 2 processes on the machine. If I looked at if I ran ifconfig, I'd see the old network. But now if I start to go in and I start to do --pid equals host, all of a sudden I start seeing all the processes on the machine, and I can keep on going. And at this point, I've turned off all the namespaces except for the mount namespace, which, of course, I don't have ifconfig, so I can't really show you the network. But basically, it's using the host network at this point. So now, at this point, I want to go in and I want to add /run. And if I go into /host, I see the real operating system. I can even do a chroot dot, and now I'm actually in the host operating system. So I guess it's hard to say, but basically at this point, I've sort of lost my ability to see my own user namespace, but I'm in the other user namespace. Matter of fact, when I talk about Docker, if you have access to Docker, if you see all these commands I just typed allows anybody to become full root on the system. It's a single command. So one of the things we've done in the latest Fedora and RHEL and CentOS images is we've taken away Docker has the ability to add a group named Docker, and so you could enter Docker without having root privileges, and we believe that you should do that through sudo. Don't use that right now because it's too easy to get root privileges and not even have any auditing. So at the end of the day, as you see, I keep on typing, and it gets more and more complex, but you can see a super privileged container. And so at this point, that's a lot of typing, right? So, and every time people do this, people are going to forget which commands, and me trying to explain to someone, okay, you got to type this. Oh, you forgot the --net equals host. Oh, you forgot the --IPC equals host. Who the hell is going to remember all that stuff? So we decided to build a new tool inside of Atomic, and guess what we called it? Atomic. Okay. So if you played around with Atomic at this point, if you played around with Atomic and you run the Atomic command on current Fedora, RHEL and CentOS, you'll notice that the Atomic is actually a symbolic link to RPM OS tree. In the next version of Atomic in RHEL, and I'm going to explain, this stuff's all going to come to Fedora very soon, we're going to replace it with a real executable. So, I jumped ahead on my slides. I just added this one. So one of the things we've done for the RHEL release coming up is we've added an image. Actually, Vaclav in the back of the room, or Vasek, I always call him Vaclav, his formal name. Vasek has been working on this tools package called RHELTOOLS. So first thing you get onto a RHEL Atomic box, you're going to install the Docker image RHELTOOLS, and guess what it comes with? GDB, ltrace, strace, source report, all the man pages, everything that we've eliminated from. This is sort of like the admin shell, and we want to get a similar image for Fedora tools and for CentOS tools. Coming soon. So once we release it from RHEL, we want to get it out to them. So that's the RHELTOOLS image, so you can be able to download an image and all of a sudden get all the tools that you were missing on an Atomic host. So we're introducing a new Atomic command. Yeah, these slides are really not scaling well. Introducing a new Atomic command, and Atomic allows you to run a container in SPC mode, or super privileged container mode. So just with the Atomic command, if you run Atomic run --SPC RHELTOOLS bin shell, it's going to actually exec that huge line. So we're just being a little nice to you, making it easy. So now if it becomes, really all this stuff, at this point, all this is a Python wrapper around the Docker command set. It's actually using Docker Pi, but allows you to instantaneously get a super privileged container, and it'll run. If you run it SPC mode, it'll save you typing all that data. And we're sort of trying to get to, a standard. It's a standard by convention. I'm not going through any standards bodies there, but that /host will be the place that the host slash will be mounted inside of containers. So since in Atomic right now, since there's a symbolic link between Atomic and RPM OS tree, we wanted to have all the commands that are currently available for OS tree that you run Atomic rollback or Atomic upgrade and Atomic status are going to be available through the new tool. So Atomic host upgrade, Atomic host rollback, and Atomic host status will exec RPM OS tree to do the exact same commands they do in the current version. By the way, Atomic is going to be shipped in both. It'll be used on regular Fedora and Fedora Atomic. It'll be used on RHEL Atomic. And the tool is smart enough to know if you're not running on Atomic, these commands disappear. So the command basically sees if RPM OS tree is installed. If it isn't, then it doesn't show you the commands. But they'll be available in both. So we get more problems here, right? So we've sort of solved the problem of missing tools. Somewhat, missing tools on an Atomic host, and now we have a command and we have a way of running containers that can actually manage the host to be able to allow you to have sort of somewhat similar feelings to what you have on a full system. But we have additional problems. My application is nicely rolled into a container image. How do I tell the user to run it? So right now, Docker images are a really nice way for packaging up software, but there always has to be this other set of information about how do I run it. Oh, you have to run it with this fancy Docker command. You have to volume mount in these file systems into it. So everybody has two things that you have to download when you install, right? When I install an RPM package, I get one thing. But right now with Docker, I have to have the install, and then I have to have some other document or some kind of installation script or some kind of systemd unit file on how do I actually run the application. Right? There's two different things. You don't get everything in one Docker image. So my application mostly runs confined, but I need one additional privilege. The IPA guys have been fooling around with splitting out all of their packages, all of their services into different Docker packages, and one of them that they came across was ntpd. So they want to run ntpd in order to keep the time synced between all their servers, and they want to run that in a container, but ntpd needs to be able to set the system time, so it needs one capability, so it needs cap add systime. So now they have to tell everybody that runs ntpd to run this special command in order to do it, which is using the cap add systime, so it gets that capability. So another patch that we've been working with Docker, and now I'm going to explain to you why this doesn't exist in Fedora yet, much to my chagrin. We've been working on the labels patch. It was once called the metadata patch. It was then called the user metadata patch. It's been called the meta patch. We've been working on it for about, I'd say, a year now. Okay, and Docker team is, Docker, if nothing else, is a little hesitant to take patches. They also have a rule that says we're not allowed to take patches, similar to the Firefox rule, that they want everybody to have the exact same Docker experience. So because of this, we've been holding back on these patches forever, and now we're at the point where we're saying we're going to start shipping it. You either merge it, and it's gotten real close to merging, so I'm hoping as soon as 1.5 comes out on Tuesday, I'm actually going out to California to meet with the Docker guys, and I'm going to tell them at that point that either this thing gets merged or it's going to show up in Fedora, and we're going to have a war. And you guys can yell at us, and we'll rename it Docker to Fokker or whatever. And we'll be done with this thing. So, and we'll see how that goes. I don't think that their investors are going to like that, but I think they'll hopefully merge the patch. So labels basically allows me to stick additional labels into the JSON format. So if you looked at a Docker image, you have this big JSON blob that explains sort of what's in the image, and then you have the image is just a bunch of tarballs. So each layer has this, and all we want is we want to instrument the content and say, here's a label. And the labels are going to say things like Red Hat. This vendor is Red Hat. Or label's going to say things like, it's licensed. Well, I guess maybe we won't say licensed because there's a reason. But when it was built, what build server was on. But these are all things that the people distributing the packages want to stick in, and it's random content, name, value, pairs. What's that? Architecture can be part of that. I think architecture needs to be in the formal JSON because I think the registries have to start to understand it. This is more like Dan Walsh decides he wants to call this thing labeled Dan equals Walsh. It's anything we want to do, right? And it's not under the control of the Docker upstream. It's anybody that wants to package it can package it. And then we can eventually develop consensus standards, okay? And this one, as I've been fighting through this, is just, let's develop standards by consensus. Let's not have to have everybody agree up front on everything, and then allow us to develop. So one of the things I want to do with Atomic is I added a run flag. So if we have the labels run, then I can specify in the image how to run this thing. So it says label run, docker run, -d, ntp, systrace. So this is the run command for running this application. If I now go out to the atomic command, I can do an atomic run this application. It will read the JSON data in there and figure out how to run it, and he will actually exec that exact command. It's as simple as that, right? This is not anything fancy. We might get fancier in the future with additional commands, but right now all we want to do is allow you to specify in the container image how to run it, and then have this little script that goes out, reads the data, and runs it. So now we can start to instrument the data to tell tools how to run it. Another thing we want to look at is one of the goals with why Red Hat's involved with containers is we're looking at containers as a new way of shipping software. So we look at this as being the next generation of RPM, right? And a way of packaging up software. We want to look at a software as a delivery mechanism. We want everything to do with that image to be able to fully install it. I package my JBoss application as a Docker image, move it to a repository, and then what? Again, we end up with these people having to build websites that say you have to execute these 10 commands to download the Docker image, and then you run this script, and you set up configuration here, and you volume mount, create directories. Or in the case of free IPA, they have this massive client install script that you have to download separately, and that'll pull in the Docker images. So we have lots and lots of ways, but you have to go to a website and download content in order to get the running Docker image. So how does the customer install it? How does it get configured to run on the host system? Where do I ship the config on the install script? So our answer is you put it right into the JSON file. So now we have two other labels we're going to be adding, and that's the install label and the uninstall label. And again, simple as can be, you, as the package developer, write your command. So in this case, we're going to do labels install docker run privilege. So we're running it in super privilege mode. Put it on the host, and then we're going to run an install script that's embedded in the image. Simple, right? And that install script's going to know it's being installed in a super privileged container. It's going to write into /host its systemd unit file to run the container. Right? Embedded right in the image. The developer has full control over it. He can write any script, anything he wants. I don't care. Right? There's no intelligence in this script to figure out this. We're not causing anybody to do it. If they want to run a GUI inside of this thing, go for it. Don't care. Similarly, uninstall. How do you clean these things up? After you've gone out and created these systemd unit files or Kubernetes configuration files and stuff like that, don't care. Here's your install script, here's an uninstall script. It's the developer of the application. He's building an application. These are somewhat equivalent to RPM pre-install scripts, post-install scripts, right? It's just, here's the package, here's how to set it up, here's how to take it down. Another thing we've talked about is sort of a meta container package. Using the same type of thing, but if you, OpenStack right now has, I don't know, was it like 15 different, Glance and Nova and, everything in the universe. So they have, there's a Kolla, K-O-L-L-A project that is looking to containerize all of OpenStack. And what they want to do is they want to have each one of these services running inside of a container, which is great, except that they still have this 1,000-line installation program that they now instead of yum installing stuff is going to be doing Docker pulls, but they still have that separately. So one of the things we want to suggest is that you build an OpenStack meta package. So a customer goes out and he says, I want to run OpenStack. So what does he say? He says atomic install OpenStack. OpenStack then goes out, Docker goes out to grab the OpenStack meta package, pulls it down. It has JSON data in it that says how to install it. It reads the JSON data, executes the install command. The install command then goes out and pulls down Glance and Nova, and Docker pulls all this stuff in. It configures Kubernetes, runs all this stuff. Kubernetes comes up. All the customer had to do to install the entire OpenStack on 15 different containers in a Kubernetes environment is execute the command atomic install OpenStack, or atomic install FreeIPA. After that point, what happens is it's up to the developers of these packages, but you start to see the power of this stuff. So we're not talking about, we're talking about these meta applications, huge, complex applications that could be simply installed just using the simple commands. Anybody any questions?
What about security?
What about it?
You're opening a root shell.
I'm opening up a root shell. You mean like RPM install, post-install scripts? It's the same thing. It's the same thing. It's just an install procedure. You can run these same commands. After you run them, you run an atomic run, and that's going to run them in a confinement. This is just during the install procedure. Right? It's just basically using the same image that's going to running an install is going to be the same image that's actually going to run the container. No, we just had an hour and a half meeting. There's no trust in Docker at all right now, okay? All right, so if we get to the point of trusting Docker, we will have signed images. So this atomic, the FreeIPA or the atomic package will come from a signed source. You will install a public key of where you're getting it from redhat.com, and you will do atomic install. You will have it pointing it to the Red Hat registry. It will download the content. It will hopefully check the content before it starts running the uninstall procedure and do it. As of right now, no trust. You get what you pay for at this point. Right. This is the problem. This is the problem you have with Docker, period, right? And relying on Docker is if you download a Docker image from hackme.com, expect to be hacked. Yes.
So, as you mentioned earlier, they also things, and also if you specify the capabilities in the JSON, you'll also not be able to trust the things anymore. How are the OpenShift people going to have like multi-tenancy in their Docker-based ecosystem?
Well, I don't think we should be downloading these images and installing them in an OpenShift environment. I'm looking at this as more of a package solution.
So the other day in the OpenShift talk, I asked them how you can actually isolate users from each other in different containers. They're like, well, Dan Walsh is going to do that.
Right, but again, an atomic run command is potentially different than the atomic install command. Atomic install and atomic uninstall are super privileged container commands. Atomic run should not be. It should be totally confined if you're running a normal Docker image. Only if I'm using the atomic install or atomic run. I can look at the labels. Right now, when I do an atomic run, and when I do a Docker run, it's running the CMD field that's specified. This is doing the exact same thing as standard Docker is doing now. The only thing is, in standard Docker right now, they have the CMD command, which can take care of things like installation procedure, uninstalls, things like that, right? Just running, how do I run this application? So whether the application, there's lots of other stuff that we need to look at to get contained. Again, I'm switching back to Dan Walsh 2 days ago. I got to tear off this and put my 7 Force 1 shirt on. So the stuff we're putting in to make sure a well-behaved container is going to run, and again, you've got to trust the application you're installing. Otherwise, don't install it. But yeah, we're going to look at things like, we're adding user namespace, we have SE Linux separation, we have seccomp separation we're adding. We want to get to the point where we can install software without requiring root, so there'd be no root privileges in this, so the container would always run as a unique UUID. So in OpenShift's case, they're going to be running them all with a separate MCS label, same way they do now. They're also going to be running them as separate UIDs, so they're going to have the containers theoretically are all going to be isolated from each other in a container. Where they have a problem is the Docker build phase, which is somewhat similar to here, in that Docker build allows me to run some privileged commands because we can't do Docker build without it being root. Okay, anybody want to see some demoing? Okay, so here we have so here I have an example of a Apache service running inside of a container. What I did is I created label vendor equals Red Hat. I did license GPL v3. Stephen doesn't like that because he thinks the image will have stuff other than v3 in it. It has a label telling you what version. Right now there's no way to say, oh, is this image version 1? Is it version 2? Is it version 3? So now let me specify version. And then I have the install command. So I'm running docker run --rm because I don't like leaving crap around. Volume mount host in there. I'm setting up logdir. So something else that the tool is going to do is if you give me a name, it's going to create var log name, it's going to create var lib name, and it's going to create etc name. You can use those if you want. You can't, and we're going to pass those in as environmental variables. So if I do an atomic install -t name, -n name, it will create content for that. So I can run this application many times and create many Apache servers, each one based on a name. Default for the name is going to be the image, so it has it. And it's also going to do a substitution on image. So where it says name equals name and image, everywhere it says image, it does a replace of the image name that you're installing. And so all it's going to do is that. After I do a Docker build, I can do a Docker info. So this is going to look at the image. Oop. It's not Docker, it's atomic. So it went into the image, so I already have one built, looks at the version, all that data, prints it out. So it tells you can examine it, probably a good idea to examine these things before you run them. And this is where it gets nerve-wracking, but I'll do it. See, install -t devconf. -n, I don't know why I'm saying -t all the time. So it went out and it ran. It shows you the super privilege command that it's running. It's substituted devconf for name. It's installing the HTTP image, and it's running the bin install script from inside of it. If you looked at the bin install script inside of the image, it's pretty simple. It's doing a docker create command to create an Apache container based on the name. It's then running systemd creates, it has a built-in template file that it's installing onto the host, does a chroot into $host, which is passed in, which is /host, runs system control, enable the service, done. I've installed an Apache server on it. I'm not going to run it because it's probably going to blow up because my ability to create from running Docker images is not good. The tool all works correctly. But when I'm done with it, if I want to uninstall, so if I went and looked at right now, I would system ctl status. What did I? Says it's disabled. I mean, it's enabled, but it's disabled currently. So I could. Why not try it out? Yeah, I don't know why my Apache doesn't start inside of systemd, but basically, it would start, if this was done by Scott, it would start. If it was done by me, it won't. So basically, it's fully plugged in, and now if I want to uninstall it, I can do an atomic uninstall. And so if we looked at the uninstall script, it's basically going to chroot into execute systemd, disable it, and then it's going to do an rm-f. So that's pretty complicated code that I wrote there to figure out how to install it. It's going to remove the system service that I put down in the first place, clean itself up. So if I do a uninstall, guys are better at this than me. So it went out and took the container off. So, and actually if I looked at, now the way the tool works is it looks for these commands inside of it. If it doesn't see an install label, it'll just pull the image onto your mix box. So we try to make it fairly robust so it will work in situations where the container is on. So basically it's going to do a Docker pull, attempt to see if there's an image in it, install it, just deinstall it. That's it. How am I doing on time? Any other questions? Yes? How would I distribute this on multiple atomic hosts? Don't know how we're distributing any code on multiple. Do we have an answer for that, Colin? Kubernetes. You should be able to execute the, however we can execute the commands. But yeah, Kubernetes should set up a bunch of Docker commands and run it. So you just have you would build your IPA or Open Stack or Apache application to understand Kubernetes, and then use Kubernetes to create instances all over the environment. Again, all I'm looking for is a really simple way to do this. Yeah. What's that? No, Kubernetes is not going to call Atomic. Atomic will call Kubernetes. So Kubernetes is not going to even know about Atomic. Atomic is a wrapper around Docker. Eventually, Atomic will probably be a wrapper around Rocket, systemd, nspawn. I think we should just get out of, we're going to start talking about containers all the time. Since we're going to have to support more than one container format, let's just use the Atomic command.
Yeah, can you say container?
Container. Yep.
There used to be bash scripts for service files.
Right.
But people did not like writing bash scripts with minor changes, and we have system unit files.
Right.
Aren't you afraid that the install SH will be mostly the same in all the packages or images, and there will be, people will be...
Right. I hope this stuff evolves. Okay.
It's a step one.
Yeah, 5 minutes, good. The question was, aren't I afraid of, these new installations? I mean, this is somewhat different than a unit file, right? This is more like to me, these are more like RPM post-install scripts. And RPM post-install scripts really haven't been standardized. I would hope that we get examples out and people start using this, we'll get some standards. One of the reasons I actually want systemd inside of the service file, inside of Docker unit files to run is because then we can take advantage of unit files inside of a Docker. So right now, if you went to the 45,000 Docker images out there, every one of them is using a bash script to start up a service. They're not using systemd at this point. So what we're working on with RHEL image, CentOS image, and Fedora image is to get systemd fully integrated in there. So now I could write a Docker build file that says from Fedora, yum install ntpd, system of control enable systemd, and that's it. That would be your entire Docker file, and you'd have systemd, journald, and Apache running inside of your container, and that would be a standard way for supporting it. The problem is a lot of people in the Docker world believe that there should be one service running in a container. I like the free service. I like to have systemd and journald because I want to hook up journaling inside of the container so it goes outside so we can get all the nice name value pairs and stuff like that outside of the container. But that's really not about the Atomic command. Anybody else? You all want to run home and play with Atomic now? You can't. So the only place that this exists in the world, well, you can go to project. If you go to my GitHub, you can actually download it. It's GitHub /Atom, not Atomic. I originally called it Atom, and then I was forced to change it to Atomic. I haven't changed the GitHub yet, but it's Atom right now. You can download this and play with it. It's going to be in the RHEL 7.1 release of Atomic. And the Docker package will come with it for RHEL 7. So when you get 7.1, you're going to get it. I'm sure within a week, our friends from CentOS will have it packaged up and ready to go inside of them. And I will hopefully come back from Docker land a week from Tuesday very happily and tell my guys to build the Docker package with Atomic inside of Fedora so it's ready to roll. with the support for labels. Anything else? Good, go get your lunch.
Už to všechno funguje. No? Mám puštěný Abert na hostu, něco spadne v Dockeru, tak Abert prostě uloží Docker inspect, jméno image z toho vykopíruje a všechno to bude tam v těch datech.
Pak to ještě dostat do kontejneru.
Co?
Pak to ještě dostat do kontejneru.
Jo.
Ale to bude v pohodě, ne? Jakože tady s tímhle.
No, jakože jo, to jsem se bál, ale rozbilo mi to strašně moje představy o tom, jak fungují kontejnery, protože já jsem teďka poznával, že něco běží v kontejneru tak, že to má jiné namespacey než init. Jenomže když pustíš ten super privilegovaný, tak on má některé namespacey stejné a já už potom prostě nevím, že je to kontejner.
Můžeme je tam nastavit, vlastně budeme to mít už teďka v base image přímo, kontejner rovná se Docker proměnou prostředí.
To je úplně nejlepší. To je úplně nejlepší.
Tohle budeme v 7.1 base image, to bude by default prostě nastavený.
Skvěle, to jsem se chtěl teďka na
to potřebuje systém D, takže...
Super. Tak je to dobrý, to vyřešíme. To je skvěle.
You should inspect it, look at the image, and try to, and if you need full compartments, put it in.
Want to say bye to who? Yep. He's said bye. I already said bye. Yep. I'm going to listen to that answer. I'll be ready.
What?